In this video, we're going to continue example 1 in section 8.2 and look at part B. So part B asks, after a long period of time on this medication, find Q, which they're calling the amount of the drug present in the body right after a tablet is taken. So after a long period of time, so maybe you've been taking this medication for several days or years, and you want to know, well, how much of the medicine is in your bloodstream when you're taking a pill? So it could be that maybe this medicine builds up in your bloodstream and just accumulates more and more as you take more pills, or maybe it levels off to a certain milligrams in your bloodstream at any given time. All right, so to investigate this question, let's go ahead and look again at that sequence Q sub n that we computed in part A. So let's just recall some of those values. So we had computed Q1 was 100, Q2 was 110, Q3 was 111. So it looks like these numbers are getting bigger. Q4 is 111.1, but do they continue getting bigger? That's the question. Or do these numbers approach a specific amount of milligrams? So Q, they're saying in this question, is then equal to the limit as n goes to infinity of Q sub n. Okay, well, what is this? The limit as n goes to infinity of Qn. We saw Qn can be written as this summation here. So then this question is saying, well, what is the sum from k equals 0 to infinity? So as this n goes to infinity, where our terms look like 100 times 0.1 to the k. So notice here that this is still a sum. What I've written here is a sum. We're adding up a bunch of terms, but we're adding up an infinite number of terms. So we call this an infinite sum. And so to expand that out, we have 100 plus 100 times 0.1 plus 100 times 0.1 squared plus 100 times 0.1 cubed, etc. And we're just going to add up all of this infinite amount of terms. Just want to really emphasize this because the object that we're playing with is always adding up another little bit, another little bit, another little bit. We're always adding up more milligrams each time we compute a term in this limit, or each time, or when we are considering this infinite sum. So we're adding up an infinite amount of terms. Okay. So we might again think that this sum is just going to blow up, get really large. Well, let's investigate this question, this limit, by looking at a table. So we saw this sum in Calculus 1, where we would create a table to determine some behavior of a limit. So let's look at n is the tablet number. And let's look at Qn, which is the amount of milligrams in the body. Okay, so we're going to construct a table here. So then we computed some numbers here already. So we had 1 was 100. We had 2 was 110. We had 3 was 111. We had 4 was 111.1. So now the fifth term, what we're going to do is just add another term when we're adding up. Oops, went too far. When we're adding up our terms here, if we introduce one higher n here, so looking in this case at Q sub 5, we're just going to add another term, 100 times 0.1 to the fourth. So what that does, and you can check this, is just adds another 0.01. So we're going to get 111.11. So you can check this. So it kind of looks like as we continue on, that our number here is just going to continue. The decimal will continue to contribute another 1. So looking at that table, it looks like this infinite sum approaches 111.1, where the 1 just repeats milligrams. And so we can conclude that that is true from looking at this table, and we're going to learn some new methods or some more rigorous methods for actually showing that that is the case. But just computing enough values in our table, we can kind of get a sense of why that should be the case. All right, so what does that mean? That means that Q is equal to, we'll highlight here, that means that Q is equal to 111.1 repeating milligrams. So the amount of milligrams in your body will level off. So we can summarize that here. So that means after a long period of time, taking the medication, there will be 111.1 repeating milligrams of the drug in the body after a pill or tablet is taken. So we just found that the infinite sum, or this infinite sum, is actually equal to a finite number. Pretty cool stuff.